Anyone who is seriously involved in the pursuit of science becomes convinced that a spirit is manifest in the laws of the universe, a spirit vastly superior to that of man, and one in the face of which we with our modest powers must feel humble.
These unexpected words were spoken by Albert Einstein, one of the greatest scientists in human history. But what does Einstein mean by a spirit immensely superior to that of humans? Some interpret these and other words spoken by the great scientist as Einstein's willingness to acknowledge the existence of a God, a creator of the universe. Indeed, on many occasions, Einstein refers to a divine spirit, but his words are not the result of a sudden personal conversion. They are the outcome of a series of incredible scientific discoveries that have rewritten the thinking of a generation of scientists. But how can a man of science, who bases everything on concrete and demonstrable facts, come to postulate the existence of a transcendent and creative entity? Today, in this video, we will tackle a mysterious, complex, and divisive topic, and we will do what many might consider impossible. By retracing the most important scientific discoveries, we will explore this immensely superior spirit that Einstein refers to, and that seems to have shaped the universe and everything we know. To fully understand the revolutionary impact of all this, it is necessary to start from the beginning, and we are certain that if you watch this video to the end, you will agree that what we now know about our origins opens up a revolutionary scenario. But before we begin our journey, if you haven't already and want to support our work, we invite you to subscribe to the channel to not miss our new videos. Science and God, two concepts that stand at opposite poles, two ways of reading and interpreting the world that appear irreconcilable and contradictory. This is undoubtedly true if we associate the concept of God with religion, but if we separate these two concepts, we will see that they are not in contradiction. But as we said earlier, let's start from the beginning. The belief that our universe was the result of a divine act was a widespread and accepted thought for many centuries. However, this thought crumbled inexorably in the face of significant scientific discoveries. To summarize, we can say that the first blow to the idea of a creator God came in 1543, when Copernicus postulated the heliocentric theory, which totally revolutionized our understanding of the universe. Shortly after, Galileo Galilei, through telescopic observation, confirmed Copernicus's theory, causing him significant trouble with the religious authorities of the time. What had been believed for millennia, that the Earth was the center of everything, crumbled inexorably. The Earth is not the center of everything. It is not the result of a creation act that makes it special or more important than everything else. It is just a planet that orbits the sun along with all the others. But this was only the first of a series of lethal blows. In 1687, Newton described gravity and postulated one of the most important laws of physics, stating that every mass attracts every other mass with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Therefore, the universe is nothing more than a machine governed by mechanical laws. A little less than 200 years after Newton, in 1809, the French naturalist Jean-Baptiste Lamarck proposed the theory of evolution, explaining how changes acquired by an organism during its life can be passed on to its offspring. Just 50 years later, Darwin's theory of evolution by natural selection seemed to definitively close the discussion on the origin of life. Thus, not only does our universe adhere to simple and clear laws of nature, but life itself also appears to be the result of chance mutations. In the following years, it was also understood that our solar system is just one of many that make up the Milky Way. In 1924, Edwin Hubble demonstrated that our galaxy is just one of infinite galaxies that comprise the universe. We can easily understand how, after these discoveries, the hypothesis of a divine creation was entirely set aside. Our universe seems to respond simply to very precise mechanical laws, and life itself appears to be merely the result of random mutations. These scientific discoveries naturally influenced philosophical thought. In 1859, Karl Marx theorized materialism, asserting that reality is fundamentally material, composed of matter and energy. Consciousness and ideas are products of matter and do not have an independent reality. A few years later, the German philosopher Friedrich Nietzsche declared that God is dead, and with him, all the moral and spiritual values of Western man.
God is dead, God remains dead, and we have killed him. How shall we comfort ourselves, the murderers of all murderers? What was holiest and mightiest of all that the world has yet owned has bled to death under our knives. Who will wipe this blood off us? Must we not ourselves become gods simply to appear worthy of it? There has never been a greater deed, and whoever is born after us, for the sake of this deed, he will belong to a higher history than all history hitherto. Must we not also become gods to be worthy of it? A new pride and a new terror might seize us, and we might face the most dreadful of all accusations, the murderers of God. And with it, all the moral and spiritual values of Western man.
If scientific discoveries and philosophical thought seem to eliminate the concept of the divine from human history, relegating it to the personal sphere and faith, something in the scientific realm appears to lay the groundwork for a crisis that will take over in the years to come. In 1850, the German physicist Rudolf Clausius introduced the concept of entropy. Clausius defined entropy as the ratio of the heat exchanged by a system in a reversible manner to the temperature at which the exchange occurs. In simple terms, an isolated ordered system will, over time, tend towards disorder and thus entropy. This is a fundamental concept in physics and chemistry because all known systems tend towards entropy. It is known as the second law of thermodynamics. The British physicist known as Lord Kelvin took this concept and applied it to the universe. Until this point, the universe was believed to be an isolated, unchanging, and eternal system. However, Kelvin theorized the heat death of the universe, hypothesizing that the universe is moving towards a future where energy will be evenly distributed. There will be no temperature gradients, and it will be impossible to derive energy to perform work, leading inevitably to its death. This crucial concept, which challenges the static and eternal nature of the universe, remained dormant in the scientific world. It would take several years for it to be revisited, and more importantly, it would take the arrival of a revolutionary theory that would change all the elements at play, so overwhelming that it would cost the lives of many of its supporters. Between 1905 and 1915, Albert Einstein published the theory of special relativity and the theory of general relativity. With these two theories, Einstein revisited Newton's concepts of gravity and improved them. But most importantly, he theorized that matter, time, and gravity are a unified entity. These are groundbreaking theories. To understand their scope, we can try to explain them simply. Imagine having a large elastic sheet in front of us. If we place a heavy ball on it, the sheet will sag. If we place two balls, the sheet will sag even more. Thus, the heavier the object, the more the sheet will sag. According to Einstein's general theory of relativity, space-time is like an elastic sheet. Matter is like the heavy ball. The more matter there is, the more space-time bends. Gravity, on the other hand, is the curvature of space-time caused by matter. As we mentioned, time is intrinsically linked to space-time. To understand this, imagine having two identical clocks, one at sea level and the other on top of a mountain. According to general relativity, the clock on the mountain will run faster than the one at sea level. This is because Earth's gravity is stronger at sea level, and the curvature of space-time is greater. If Einstein's theory revolutionizes our understanding of time, space, and matter by showing how closely they are connected, it initially remains tied to the principle of a static universe. When formulating his theory, Einstein believed in a static, eternal, and immutable universe. Around the 1920s, astronomer Edwin Hubble observed the emission spectrum of various galaxies and noticed that the light from many of them was redshifted. Redshift is a phenomenon that occurs when a light source moves away from the observer. The greater the redshift, the faster the source is moving away. This observation suggested that the universe was not static as previously believed, but that galaxies were moving away from each other. At the same time, the Russian mathematician Alexander Friedmann, studying Einstein's theory of gravity, demonstrated through his famous equations that the universe is expanding. Concurrently, the Belgian priest Georges Lemaitre, based on Hubble's observations, theorized that the universe originated from an event, a singularity he called the primeval atom. This was the postulation of the theory that would later be known as the Big Bang. This theory was immediately opposed by the entire scientific community. Einstein himself initially refused to believe that the universe was not static and wrote scathing words. However, later, when presented with Friedmann's equations, he acknowledged their correctness and wrote an article recognizing this new, shocking reality.
In an earlier note, I criticized the cited work. However, my objection, as Mr. Krutko and a letter from Mr. Friedmann have personally convinced me, was based on a calculation error. I am now convinced that Mr. Friedmann's results are correct and enlightening. They demonstrate that, in addition to the static solutions of the field equations, there are time-varying solutions with a symmetric spatial structure.
Einstein's admission shook the scientific world, overturning everything that had been believed up to that point. It was not just the idea that the universe was expanding, a theory confirmed by Friedmann's equations, but also that it might have had a beginning, as postulated by Lemaitre. And if the universe had a beginning, it could very likely have an end. While the Copernican revolution had faced severe repression driven by the Catholic Church, the hypothesis of a non-eternal and non-static universe, one that had a beginning and thus erased the idea of the immortality of matter, was something many found unacceptable. But this new theory posed more than just that danger. Among the first to grasp the insidiousness of this new line of research was Joseph Stalin. Initially, the theory of a beginning to the universe was well received in the Soviet Union, and even seen as a confirmation of the materialist model postulated by Marx. However, over the years, Stalin perceived it as something that could undermine materialism, because the idea of a beginning of the universe dangerously approached an act of creation, which was dear to supporters of the divine. During the era of Stalinist purges and state atheism, this new theory was violently opposed, and researchers who supported it were expelled from universities, with many forced to seek refuge abroad. If Stalin's regime viewed the idea of a non-static universe with finite time unfavorably, the same was true in Germany, where the seeds of Nazism were taking root. The theory was seen as an enemy to be eliminated, partly because these new ideas were championed by Jewish scientists like Einstein, and partly because, unlike Stalin, the Nazis believed in a pagan religion based on the Aryan race cult. The Big Bang theory, however, was viewed as a scientific theory that did not require religion to be explained. Although the concept of an initial act closely resembled Christian ideas of creation, which were frowned upon by the Nazi regime, it also posited that the universe and life itself were the simple result of mechanical laws. With the rise of National Socialism, the books of all authors advocating these new theories were burned, and many scientists, including Einstein, fled Germany. Those who could not or did not want to escape abroad, like the mathematician Felix Hausdorff, were deported to prison camps where they met their deaths. After the war, the fate of the supporters of these new theories did not improve. Friedmann was entirely forgotten, and no one believed in Abbot Lemaitre and his theory of the primeval atom anymore. It was precisely during these years, on March 28, 1949, that the well-known astronomer Sir Fred Hoyle appeared on a BBC broadcast and was asked what he thought about the possibility that the universe might have had a beginning. Annoyed by what he considered an inappropriate question, the famous astronomer irritably exclaimed the phrase that would give the theory its name.
The cosmos was not born from a Big Bang.
It will take several more years before the scientific community definitively accepts the Big Bang theory. If we want to pinpoint a precise moment when this happens, we can say that in 1964, Arno Penzias and Robert Wilson discovered the cosmic microwave background radiation, and in 1970, the COBE satellite measured the temperature of the cosmic background radiation with great precision. At this point, there are essentially two predominant hypotheses. The first is entropy. If you remember, we mentioned the second law of thermodynamics, followed in the latter half of the 19th century by Kelvin's theory regarding the death of the universe. According to this theory, the universe is destined to die. Sooner or later, all the energy present will be consumed, and the cosmos will go dark forever. Opposed to this theory are multiple alternatives, the most accredited being the Big Crunch, which many of us studied in school. It essentially states that after a period of expansion, the universe will undergo a phase of contraction that will cause it to collapse back into a point of high density and temperature, similar to the state from which it originated with the Big Bang. This could hypothetically start a new cycle. However, the Big Crunch was almost entirely disproven in 1998, when observations of light from supernovae showed that our universe is not only expanding, but that this expansion is accelerating due to dark energy, a mysterious force that counteracts gravity and causes the acceleration of the universe's expansion. If the universe continues to expand at an accelerated rate, it will never have the opportunity to contract and collapse on itself, thus disproving the Big Crunch theory. Now, we enter the heart of this video. Everything said so far was necessary to clarify some fundamental concepts we will discuss shortly, and to understand the historical moment we are currently experiencing. To recap, we can affirm that today we know our universe had an origin, which produced all the basic elements that gave life to everything we know about the universe. These elements not only make up the matter we observe, but are also the building blocks that allowed life to arise. Life, through evolutionary processes driven by chance, has led to the development of complex organisms from simple ones. So, if everything we know describes a material and mechanical universe, why would a scientist of Einstein's caliber, and he is not the only one, as we will see later, claim to believe in a spirit immensely superior to that of humans? Here, we need to take a step back in the history we have told so far. While theories such as relativity, the Big Bang, and those related to the biological development of life were being postulated and affirmed, the first discoveries were simultaneously being made that would incredibly lay the groundwork for overturning everything that had just been outlined. But let's proceed in order, and start from the beginning.
The universe embarrasses me, and I cannot believe that such a clock exists without there being a clockmaker.
Despite his skepticism towards organized religions, Voltaire in the 18th century expressed his awe and wonder at observing the universe through these simple words. The knowledge of that era was still rudimentary, but when, in the early 20th century, through the study of the infinitely small, we began to scrutinize the mechanisms of this clock described by Voltaire, we started to understand an extraordinary reality. As we mentioned in the first part of the video, it was understood in the early 20th century that our universe had a beginning thanks to an event known as the Big Bang. However, what scientists would soon discover is that this event was not a moment of pure chaos. Every instant was meticulously regulated to define everything we know about the universe today. In fact, even an infinitesimal variation in the course of events, on the order of a fraction with 64 zeros followed by a 1, would have prevented our universe from forming. Now let's delve into this extraordinary series of numbers and all the consequences they entail.
The most catastrophic event we can imagine, the Big Bang, upon closer inspection, appears as something finely orchestrated.
This is an observation by George Smoot, who received the Nobel Prize in Physics in 2006 for his pioneering research on cosmic microwave background radiation. This consideration stems from the analysis of all the events that led to the formation of our universe. As we mentioned, the study of the Big Bang has led many scientists to argue that it was not a chaotic event from which our universe emerged, but rather that it could only form thanks to precise events and mathematical combinations. But what are these mysterious fine-tunings? At the beginning of time, an instant that can be quantified as a number where after 0 and its decimal point, there are 42 zeros followed by a 1, our universe had a radius billions of times smaller than that of a hydrogen atom. At this moment, its temperature was 100 trillion degrees. Even in this epoch, when matter, structure, or any elements did not yet exist, everything was already extraordinarily ordered and regulated. The four fundamental forces that give life to our reality were unified. At the center of this astonishing revelation are the four fundamental forces that gave rise to our universe: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces govern every aspect of our universe, from the structure of atoms to the dynamics of galaxies. But their existence is not the only surprising fact. What is also surprising is their incredible proportional relationship. From the very first instant, these forces had to be balanced with absolute precision. If even one of them had been even slightly different, the universe as we know it could not have existed. For example, if the force of gravity had been infinitesimally stronger or weaker, stars would not have formed, and the universe would have remained an immense cloud of cold gases. If the strong nuclear force had been slightly different, stars would not have been able to produce energy through nuclear fusion, preventing the formation of heavy elements like carbon and oxygen, essential for life. If the cosmological constant that determines the rate of the universe's expansion had been different, the universe would have expanded too quickly or too slowly, preventing the formation of galaxies and stars. To better understand this concept, let's imagine the universe as a gigantic construction game with billions of pieces to assemble. To make this game work, precise rules must be followed, just like in Lego instructions. These rules are like special proportions called coupling constants, which have no units of measure, as if they were magic numbers. Think of these constants as special pieces that must be placed in the right spot for everything to work. If even one of these pieces were different, even by a tiny bit, the game would no longer work. The universe would be a completely different place, a place where not only life would be impossible, but even the formation of matter as we know it would be prevented. One of these constants is 1 over 137, representing the strength of the electromagnetic force, a fundamental force that holds atoms together and allows life on Earth. The value of 1 over 137 is truly special. It is a pure number, without any units of measure, like a secret code of the universe. And the incredible thing is that this number is extremely precise. If it were even slightly different, the universe as we know it would not exist. The famous physicist Richard Feynman was so fascinated by this number that he called it an unfathomable mystery.
It is one of the most enigmatic puzzles in physics, a magic number that is presented in the utmost mystery. One could almost say that this number was written by the hand of God, and we do not know how he moved his pencil.
But there are many other extraordinarily precise elements that allowed the creation of our universe, such as the cosmological constant. To fully understand this concept, let's imagine the universe as a gigantic balloon being inflated. The more air you add, the more the balloon expands. The cosmological constant is like the force that drives this balloon to expand faster and faster, even without adding more air. Now think of this constant as a special number, a magic ingredient that regulates the expansion of the universe. Its value is incredibly small, almost zero, yet it has a massive effect on the fate of our cosmos. A tiny variation in this value could cause the universe to either collapse in on itself like a deflated balloon, or expand so rapidly that it disintegrates completely. These are just two examples of how the forces that shaped our universe are incredibly precise and unique. Unique because we must consider the billions of possibilities where things could have turned out differently, but they didn't. In 1974, British cosmologist Brandon Carter proposed a method to estimate the probability of our universe forming as we know it. Carter arrived at an approximate estimate of 1 chance in 10 circumflex 156, 1 in 10 to the 156th power. To grasp the magnitude of this number, we can imagine it as a grain of sand among a trillion beaches, or a probability so small that it far exceeds the number of atoms in the universe. Clearly, the discovery of these precise fine-tunings has not gone unnoticed, and has led many scientists to believe that our universe was somehow ordered by something unknowable or structured by something unfathomable from the very first moment. But at this point, if anyone thinks this is a view held by scientists influenced by religious dogma, they are greatly mistaken. There are many examples of secular or even atheist scientists who have been struck by the evidence of these improbable fine-tunings. At the beginning of the video, we talked about Einstein, but among many others, we can mention Stephen Hawking, an agnostic astrophysicist who reflected extensively on the meaning of fine-tuning, or the great scientist Paul Dirac, a man free from any faith-based dogma, who wrote in 1933.
One could perhaps describe the situation by saying that God is an excellent mathematician and used very advanced mathematics to construct the universe.
At this point, it becomes very difficult to believe that our universe structured itself by pure chance, following all these improbable coincidences. Clearly, there are theories that try to hypothesize scenarios where this might be possible. Among the most well-known is the multiverse theory, which suggests that it is impossible for all the peculiarities of our universe to be the result of chance. But this would become possible if ours were just one of billions upon billions upon billions of universes where every conceivable possibility has occurred. This is an undoubtedly fascinating theory, which itself branches into many other theories. However, it is still in development and has not been proven. It also leaves many unresolved questions, such as the nature of the origin of that singularity that would give rise to all the universes. But our journey doesn't end here. There is another mysterious aspect of the universe that deserves our attention: life.
Nature transitions so gradually from the inanimate to the animate that their continuity makes the dividing line indistinguishable, and there exists a realm that belongs to both orders, as plants come immediately after inanimate objects.
The idea of Aristotle, that inanimate matter could gradually and simply transition into life, persisted for many centuries. It wasn't until 1668 that Francesco Redi, through a simple experiment, demonstrated that the transition from inanimate matter to life is not at all automatic. At that time, it was believed, for example, that worms naturally generated from decomposing meat. To prove this wrong, Redi placed fresh meat in various jars. Some jars were left completely open, others were sealed tightly, and others were covered with a gauze that allowed air to pass but not insects. Clearly, in the sealed jars, the meat was not infested with worms. In the open jars, however, the meat became filled with larvae, carried by the flies that landed on it. This simple but effective experiment was a crucial step towards abandoning the idea of spontaneous generation of life. However, the notion that life could generate from inanimate matter was hard to eradicate. It took another 200 years, and the experiments of Pasteur, to show that microorganisms, then believed to cause spontaneous generation of life, actually came from other pre-existing microorganisms, definitively disproving the idea that life could arise from non-living matter. But the idea that life could emerge from inanimate matter has never entirely died. This is how Darwin expressed himself in 1850 in a letter to a colleague.
But if we could imagine that in some warm little pond, with all sorts of ammonia and phosphoric salts, light, heat, electricity, etc., a protein compound was chemically formed, ready to undergo still more complex changes, it is clear that this substance would be instantly devoured or absorbed, which would not have been the case before living creatures were formed.
Darwin's idea, later revisited in the 1960s and 1970s, proposed that in a primordial soup, the elements that would form the building blocks of life could spontaneously arise through simple chemical reactions. For many years, scientists attempted to test this hypothesis, and the most famous Miller successfully recreated the conditions of a primordial atmosphere in his laboratory. Using a mixture of methane, ammonia, and hydrogen boiled in water, and subjected to an electrical discharge to simulate lightning, he managed to create 13 of the 22 amino acids, which are the fundamental building blocks of life. This experiment was considered a success as it demonstrated that, in a hypothetical primordial soup, it was possible to create the compounds that form the basis of life. However, this is only partially true. While specific conditions can recreate these elements, the transition from inanimate matter to life is very long and laborious. To understand the difficulties of this transition, much like we did with the birth of the universe, we need to delve into the details and analyze the processes underlying what we call life. The development of the electron microscope has allowed us to explore the world of the infinitely small. Today, we know that living beings must be composed of at least one cell, which is already a highly complex structure. A cell, to be viable, must have a membrane that separates it from the external world. It must possess a genome encoded in a DNA molecule consisting of at least 250 genes, which means 150,000 nucleotide pairs assembled in a precise order. Additionally, an RNA system is necessary to decode the information in the DNA, along with a ribosome capable of interpreting the RNA. Finally, the cell must be able to synthesize at least 180 different proteins and several dozen enzymes. From this initial description, we can see that even a theoretically simple organism, such as a single-celled bacterium, is already very complex. Analyzing the specific elements that compose the cell reveals not only complexity, but also something extraordinary. Every living being, whether a human, a plant, or a bacterium, needs DNA. Deoxyribonucleic acid is a long macromolecule composed of 2 chains of 4 nucleotides: adenine, thymine, cytosine, and guanine. Arranged in an extensive alternating sequence, these nucleotides represent a code. Keep in mind this 4-factor system, as we will return to it later. DNA is present in every living being, containing all the information that will constitute the organism, and it is an incredibly complex system. To write down the information contained in a nucleus just 0.006 of a millimeter in size would require 1,000,000 pages. This is the best data storage system we know, billions of times more efficient than the best hard drive currently on the market. Unsurprisingly, when Francis Crick discovered the structure of DNA in 1962, he was so impressed that he stated such a structure could not be the result of chance. But we are just beginning. Many more extraordinary facts await us. The cell of even the simplest organism on Earth, in addition to DNA, requires proteins. A cell cannot exist without them, because proteins, along with RNA, perform all functions except for storing information and providing instructions to create new organisms, which, as we have seen, is the role of DNA. Proteins are not as simple as we might imagine. They are composed of hundreds, in the case of the most basic proteins, to thousands of smaller units called amino acids. Biologists have compared amino acids to the 26 letters of the alphabet because they can combine in an enormous number of sequences. Using this analogy, we can say that the words and sentences they form are proteins. Today, we know approximately 80,000 different proteins. In reality, the discussion is even more complex because amino acids can only combine in specific ways. But for simplicity, we will set this topic aside. As we mentioned earlier, information is present in DNA, but this information must be translated in some way to create proteins. To clarify, it is like reading instructions in a book, the DNA. Someone needs to take this information and put it into practice. This task is performed by the ribosome, which acquires the information and transforms it into amino acids, the building blocks of proteins. Remember, DNA is composed of 4 elements: adenine, thymine, cytosine, and guanine, while proteins are composed of amino acids. The ribosome translates the language of DNA into a new language that gives rise to proteins. To simplify further, we can imagine DNA as an instruction manual in English describing how to build a car. The ribosome reads the manual and translates it into step-by-step instructions that a French worker can understand to assemble the car. Incredible, right? But it's even more incredible to imagine that this complex system was present from the moment the first cell of the first living being formed. We don't know how all this came about, but it is even more interesting to understand how nature could have activated this ultra-complex system more than 3 billion years ago, which has characterized life on Earth since its inception. Even more challenging is understanding how this system could generate itself through random events. By examining these aspects, and there are many more, as we are simplifying very complex processes, we can easily understand that Miller's experiment, which produced simple amino acids, is extremely far from creating the first living organism. To simplify once more, we can say that Miller's experiment produced the equivalent of a bolt for a car, but creating an entire car requires much more work. At this point, just as we questioned the origin of the universe, we must also ask whether chance and evolutionary mechanisms are sufficient to explain the formation of such complex elements. And let's not forget, we are currently talking about the formation of a single cell. Many scientists have tried to answer this question by calculating the probabilities of such occurrences. They started by estimating the probability that chance could create a protein. While a protein is not a living being since it is part of inanimate matter, it is indispensable and necessary for the creation of life. So, what is the probability that a chain of various amino acids randomly arranges itself in the correct order? This probability has been estimated to be about 1 in 10 to the power of 1500. In simple terms, this would be like winning the lottery by guessing a combination of 6 numbers out of a 623 million chance. for 170 consecutive drawings. However, several scientists, including Sir Frederick Hoyle, went further and calculated the probability of a simple bacterium forming by chance. They arrived at the astounding conclusion that it has a 1 in 10 to the power of 40,000 chance of spontaneously creating itself.
The probability that life arose on Earth by pure chance is so small that it is akin to believing that a tornado sweeping through a junkyard could assemble a functioning Boeing.
Is it possible, then, that the universe and life are the result of a series of fortunate events? Is it conceivable that the processes leading to the appearance of all living beings are the consequence of random events that have produced increasingly complex organisms? There is no definite answer to these questions. However, what we know today is that the universe and life itself did not have unlimited time to develop. Our universe had a beginning and will very likely have an end. If we consider the combination of chance and probability relative to the time available for all these events to occur, our opinion is that this might not be possible. Recent discoveries highlight the improbability that some events could be solely dictated by chance or evolutionary outcomes. It is more realistic to believe that something significant currently eludes our understanding. As we have seen in our historical overview, scientific thought is always evolving. For a new theory to be established, it requires not only a lot of time and precise evidence, but often must overcome resistance to new ideas that can overturn established certainties. This is because groundbreaking scientific discoveries influence not only the thinking of the scientific community, but are so impactful that they change the thinking in all areas of human knowledge. The theories of the 19th century paved the way for determinism and materialism, which became philosophical, political, and cultural disciplines that still represent the foundations of Western thought and beyond. In light of all this, it is still legitimate to ask today whether our universe is pervaded by a force that determines a purpose and inevitably leads to the creation of life. Similarly, it is also legitimate to continue investigating and understanding if everything we know is the result of mechanical laws waiting to be discovered.
Everything is determined by forces beyond our control. Everything is determined for the insect as well as for the star. Human beings, plants, or star dust, we all dance to a mysterious tune played in the distance by an invisible piper.
We've reached the end of the video. Thank you for sticking with us until now. We apologize if there were any inaccuracies or oversimplifications. The story we've told is indeed very complex and not easy to summarize in all its aspects, and it certainly deserves further exploration. Now, we are genuinely curious to know your opinion. Please write in the comments what you think. If you enjoyed the video, subscribe to the channel to support our work and to make sure you don't miss our new videos. See you in the next story.